All right, here we go. Two examples of trig proofs. Two really good examples showing us the value of a couple techniques here. Trig, you have to be a unique person to love trig proofs. I consider myself unique. I love trig proofs. I can welcome this identity into my soul, deep into my soul. Let it marinate. Let it sit in there. Let my soul work on it, and out pops the product of that is a direction, is a path, is a shining light to my solution, to my proof. What I see here, I have let this trig proof marinate in my soul, and I see the light. I see the light. I see two terms on the left. I see one term on the right. I see that we have to start with the left side, and we're going to combine those two terms into one term, and I see the light. If I want to combine these, I need a common denominator, so it's going to help me to change things to sine and cosine. This is a common technique. A lot of times, sine and cosine are our best friends. All right? Let's see here. The common denominator is going to be the two denominators multiplied together. So the common denominator is going to be sine of x, cosine of x. And I have to multiply the left fraction by cosine on the top and the bottom, and the right fraction by sine on the top and the bottom, so that I get my common denominator. So on the left side, I have cosine squared of x. On the right side, I have sine squared of x. I see the light. Pythagorean identity, cosine squared plus sine squared is 1. Sine of x, cosine of x on the bottom. I can split that up into two fractions multiplied together. And by George, if 1 over sine of x isn't cosecant of x, and 1 over cosine is secant of x, and I think we have a solution. Woo! All right, trig proof number 2. Let's welcome this into our soul. Once again, I see two fractions on the left. I see one term on the right. We are going to start with the left, and we are going to combine those fractions just like we did in the last one. So I'm going to start with the left. Okay. And also, just looking ahead, if my final step needs to be 2 cosine squared, I'm going to anticipate, I've got sines and secants here, I'm going to anticipate that at some point I'm going to have to change things to sine and cosine as well. Well, let's see what happens. Let's combine these fractions. Oh, I actually didn't want these to be squared. I let the wrong trig proof into my soul. Sometimes that happens. You know, sometimes it just happens. Where you don't want your secants squared. I hate when I square my secants and I don't want them squared. That really drives me nuts. This proof is set up this way for a reason, so that when we multiply those two denominators, we're going to get a Pythagorean identity. Alright, so in order to combine these, we need to multiply the left fraction on the top and the bottom by 1 minus secant of x. 1 minus secant of x. And the top and the bottom over here by 1 plus secant of x. 1 plus secant of x. And what does that give us? On the bottom, we're going to get a 1 plus secant of x times 1 minus secant of x. On the top, we're going to get a sine squared of x, 1 minus secant of x, and then plus sine squared 1 plus secant of x. Nice. How can we simplify this? Well, we can definitely rewrite the bottom as 1 minus secant squared of x, just by foiling that. And that's why it was set up so we can get there. I'm hoping that that's a Pythagorean identity. On the top, however, we can pull out a sine squared. I love to factor out sine squares. Whenever I factor out sine squared, something good always happens to me. It's just crazy how that works. 1 minus secant of x. And then what's left over here is plus, that's what's in the middle, plus, and then 1 plus secant of x is what's left. I love that. I told you, good things happen. Good things happen when you factor out sine squared. What I see is 1 plus 1, which is 2 sine squared of x over, 1 minus secant squared. 1 minus secant squared is going to be negative. It's actually negative tangent squared. I'm going to go up and sneak a little negative sign into the end of our proof. I did not foresee that happening. That negative sign, it snuck in there. But let's just run with it. All right. So we have to get to, we're trying to get to negative 2 cosine squared. We're trying to get to negative 2 cosine squared. So I'm hoping that when I manipulate these things, changing the sine and cosine, that we'll get there. All right, so negative 2. Just bring that negative in front of the 2, that's fine. Sine squared. And if I'm dividing by tangent, it's the same as multiplying by cotangent. I like that step, because now it makes it easy for us just to change cotangent to sines and cosines, which is cosine squared over sine squared. And sure enough, those two sine squareds cancel out, and we get our negative 2 cosine squared. Oh, I love it. I love it. I love it when a proof works out like that.